Hey everyone, how's it going? This is your friend Venkat Ramakrishnan at Software Testing and Quality Talks, bringing you the next episode of Software Testing and Quality. Today we have a special guest on our video, a guest who specializes in security testing and who is passionate about educating the community on security testing. Please welcome Sylvia Killinen. Sylvia has been working on software security for the past 13 years and has an impressive record of projects that she has handled. Sylvia, we have been talking about software security for a while, and you have always wanted to talk about security strategy. So could you please tell us more about it?
Absolutely. Thank you for inviting me here to talk about security testing and test strategy. Let's jump right in. First off, software testing and information security are very similar work. In fact, information security is just really aggressive testing, at least in the AppSec being application security and AppSec testing or penetration testing or pen testing space. Whether that be threat modeling, actual testing, hands-on, or red or purple teaming. Without getting too much into specific tactics that are used, which are always dependent on the technology under test, software testers will find the strategy of information security assessments to be familiar. A good assessment is all about finding where weaknesses might be, then creating manual or automated tests to see if a potential threat is really present in the software. It's close to the analysis that goes into risk-based testing, so practitioners of that technique will find this very familiar. The main difference is that RBT often relies on simplified and subjective measurements such as estimates of likelihood and impact. There are more refined tools for talking about risk in information security practices.
Okay, so what are some of those tools that you are talking about?
The best tool I have for building a test strategy from the ground up is threat modeling. It's a more scientific way of measuring risk in specific areas of a system. The idea is to think through every interaction in some repeatable way, recording risks as you go, and then present a list of possible vulnerabilities for analysis. Once you have your threat model, that complete list of potential problems, you can prioritize them and start building test cases, but it's useful for more than just that. The end result should be a tool for communicating about risk, not only for security team members or software testers, but anyone with an interest in the security and stability of the system, be that developers, CISOs, other security folks, ops teams. It's worth a note that threat modeling isn't just about software. It's possible to create threat models for mechanical systems, business processes, and entire companies. It's the process of figuring out architecture-level weaknesses in software. For a company, I'd be looking at things like supply chain, their permissions, their access controls. Where does authority come from and what can a given person do? By exploring every path that data flows or that authority can act, or by examining the architecture, which a company has architecture just like software, against whatever security requirements your system has. So I feel like that's a little bit vague, but in this case, the vagueness is necessary.
Go ahead.
A company that handles a lot of confidential information will have very different requirements than a company who never handles personal information, but handles a lot of financial data. Both of those will be different than a software application sending encrypting messages or a company that handles no sensitive data whatsoever.
Excellent. How does threat modeling works? How do we go about it?
Sure. The first step of a threat model is knowing your security requirements. And most businesses will have some idea of this already. Almost every business knows what valuables it has. What are their assets? The people in charge should already know a few ways the business can lose money or spill data, and they've probably already thought of ways to avoid those dangers. But again, that's subjective and probably partial. The advantage of formal threat modeling is that it provides a more complete and more actionable picture, as well as specific steps to thwart attackers. If those security requirements are your first step, knowing something about how your application or your company will work is the second. Whether that's basic architecture, an idea of data flow, or a summary of how a user will interact, doesn't matter. Those are all different methodologies to arrive at the same endpoint. That model will grow and change alongside the software and the requirements. You step through it in that systematic fashion and write everything down. not just the end results, but the thought process, because you'll probably want it later.
Absolutely. We will have to keep updating the model as the requirements and the software changes. Which brings us to the topic of threat modeling tools, because presumably it's pretty difficult to analyze these manually. What tools would you suggest to do the threat modeling?
Each process that I have used actually is a manual process. And that's because, at least at the moment, automated processes do not understand context very well. And everything in threat modeling is about context. I've used a couple of automated tools that can assist with the process, but in the end, it's going to have to be a person thinking through those interactions. A tool may catch the low level, oh, there may be an architectural vulnerability here, but in order to prove that it's really there, it's still going to require human interaction. I know that Irius Risk is a threat modeling tool. I've used that one. It's pretty interesting. Again, you're still going to have quite a lot of manual interaction. As far as that manual interaction goes, there's several different methodologies. I personally like Trike, which you can find at octotrike.org. It's open source. I highly recommend it. But you can get good results with any methodology your company has chosen. I've used likelihood versus impact, which can be quite complete if you write it all down or start from a complete architecture diagram. I've used Microsoft Stride and Trike, and there's certainly a lot more tools and methodologies out there. That's not a complete list. I like tools that create a detailed record of the thought process leading to a given vulnerability being found, accepted, or discarded. It's easy to see how you went through the system and just what you expect the results to be.
Okay. So what are some of those tools that you are talking about?
Trike is the only threat modeling tool I've seen that's not solely about software. The process of stepping through each threat is inspired by the hazard and operability, or HAZOP process, used by chemical, medical, and nuclear industries. It's flexible enough to use for non-IT applications, such as threat modeling companies, and thorough enough to be confident in the results.
That sounds like a very heavy process. How does it fit into DevOps?
You're not wrong, it is heavy. Just like any other testing process, threat modeling can be lighter or heavier as you need it to be. If you're starting with a complete system in a waterfall process, you're going to be doing quite a lot. If the threat model is begun early in the process and kept up to date as small features are added, it can be modified a lot more quickly. You can apply shift left to threat modeling just as you can to software testing.
That would be a great idea. You talked about context when you talked about the importance of manual process in modeling. Machine learning can produce predicted outputs given a set of inputs. Do you think machine learning can help in this context?
Maybe. It's not just the context of pattern matching known issues against new inputs. It's also the legal and regulatory context. And I have yet to encounter a machine learning system that can handle the complexities of GDPR, never mind other less common regulatory frameworks.
Yes, I think we are still working on the regulations worldwide. It is still evolving. Let's discuss some strategy stuff. Given an app, say a mobile app, how do you go about doing threat modeling for it? What do you do?
Well, I'd start right from the requirements. If it's an app that handles, I don't know, pets' names, that's not personally identifiable information in any framework I know. That's not particularly sensitive data. Hopefully somebody hasn't used it as their password across their banking websites. I would say this app is handling pretty low sensitivity data. And I would start from there to find out, what are the other assets? What might this site have that is of value? Now, how do I get it? This is very much like the process of functional testing, where you're saying, what should the user do, and how should I verify that everything they should do works? But it's flipped upside down, right? I'm saying, what should the user not do, and how should I make sure that I can or cannot do those things? If I have a threat model, I'd use it to drive my strategy. The highest priority threats, those with the worst consequences for the users, the business, and the digital or physical environment, get tested first and most thoroughly.
Does the security strategy depend on the tech stack, infrastructure, programming languages used? Do they have an impact on security?
Programming languages and development frameworks are going to make fewer changes than infrastructure shifts at the level of strategy, and even at the level of tactics. A function that hashes a string is going to have the same test cases no matter what language it's written in. There's a couple places where the framework and the programming language really do matter and will make changes to the strategy. One is in the subtleties of implementation. You need extensive knowledge of the language in use. A quick skim is not going to catch subtle errors, and a threat model will not help if you have poor understanding of the technology under test. The second way it changes things is the tools the language or framework gives you to address the threats you find. Those are going to be different sometimes from version to version of the same language. Changing infrastructure really gets interesting. And certainly something as dramatic as going from a monolith to microservices or containerizing an application. The best ways I have of analyzing an application are architecture and data flows. Infrastructure changes change both of those, but it's a reworking of part of the threat model rather than changing the whole thing unless a complete redesign is on the table. Fortunately, that's pretty rare.
Do you use any architecture tool for analyzing the architecture and the data flows?
Well, I either use the trike spreadsheets and then go through that HAZOP process I mentioned earlier to break it down. Or if I need an architecture diagram, I'll draw it out sometimes on a whiteboard, sometimes in a software tool such as draw.io or diagrams.net.
Okay, cool. How do you keep updating your strategy on evolving threats?
That's really a never-ending learning process. That's part of what drew me to software testing in the first place, and the learning curve is even higher in information security. That's very attractive to me. If I see new information about an evolving problem, or to use the InfoSec jargon, threat intelligence, I'll go back to my threat model to see if I have anything the new threat might affect. It's useful to keep an eye on new information for exactly that reason. And there's kind of two ways that can fail. One, somebody sees the threat intelligence and then they don't go back to the threat model to see if it changes anything. Two, they do go back and they don't see what change should happen.
What about the operating system considerations, like security patches? Do you consider them as part of your strategy?
If the system is something that can be patched, which is not every system, but most of them, right? We hope. I have a discussion with the security operations team, who's usually in charge of handling that sort of thing, just to make sure there's a plan. If the system under test can't be patched, there'd better be other protections in place, and it might be my role to figure out what they should be. That may be network protections, that may be application level protections, it may be blow this thing away every 4 months and make a new one, programming languages or framework. The capabilities of the operating system will make a difference in the subtle implementation quirks and in the tools they give the developer to address threats. So, for example, Windows 7 has very different access controls than Windows 10. If I know my system has to support both of those, I have to take that into account when I'm suggesting solutions for a question around access controls. But a good threat model should already include some variation of attacker bypasses access controls, which would then start an investigation into what other defenses exist. For example, if there's something that says the attacker has remote command execution in the OS, that is very, very bad. They own your computer. They can use it to get to other things. If we look at that and realize that means they can bypass our nice access controls, we can generate cases around what happens if they do. The more comprehensive the model, the more likely we've already thought about that point of failure. And that should always be the punchline. You tried something cool, but we already thought about it.
Yeah. So do you have a strategy for ransomware attacks?
Personally, I keep offline backups. My work is largely around protecting systems rather than restoring them after the fact, but that's another place where I'd likely work with security operations on designing a strategy.
Wonderful. It looks like a whole lot of information to grasp. You're doing an awesome job. By the way, do you have an example that you can share with us today?
I don't have one today, but in another session, I think that's something we could do. It would be interesting to generate a quick trike model for a common website and then step through it so that the thought process is more obvious. This was a very abstract discussion about what you should be thinking about and how you might generate cases and then use that to drive your test strategy. Seeing some implementation would probably be really good.
Thank you so much for your time today talking about threat modeling and security test strategy. It was very thorough, involved, and detailed talk which explained the basics to us. Let's do some more talks with you related to security in my channel and possibly go through some scenarios or examples.
I look forward to it. Thank you for hosting me. Bye.
Bye-bye. All of those who listen to this podcast, thank you so much. Please stay tuned to my YouTube channel by subscribing to my channel, as I am in the process of bringing out regular videos on various aspects of software testing and quality. See you soon.